Hi, everybody. Today on the Data Show, we're going to talk about climate change and show you some data on some areas of storms and billion-dollar disasters. They're talking about billion-dollar disasters right now. Guess what? There's been billion-dollar disasters in the past, like 1980, 81. All that on the Data Show. I've been talking about climate change in the past couple of data shows, and I think it's pretty important to understand, the climate change aspect and what's going on. So first of all, defining climate. So I talked about data definitions last time. Let's talk about climate. So climate is weather that has changed over a period of time. Although if you look at definitions of climate, it's kind of like, it could be 10 years, could be 30 years, could be, whatever number of years we talk about. And the other area that I've talked about with climate change was the idea of trying to put fear into people. And this is something that's really, really important, is to understand what to be afraid of and what to not to be afraid of. And I think what's happening is that media, and I talk about media as just TV, but it's not just TV. It is any type of radio news, any type of talk shows, anything that puts people into a panic. I think it's people just need to calm down and take a look at the data that's available to them. And all this data that I'm showing you every single week is available to you. All you have to do is take a look at it. I give you the references in most of the situations. You can go take a look at this data yourself. And I think it's very important to understand what the difference between something like a millimeter and an inch is. Because a lot of times what happens is that and I don't blame scientists a lot for this because they have to deal with metric systems anyway, so they kind of use it. But they talk about 10 millimeters, and if you don't understand the relationship between a millimeter and an inch, because we were brought up in inches and feet and yards and those types of things, all of a sudden it's a millimeter. 10 millimeters might seem like a lot to you, and we'll talk about that different areas and how to kind of make that transition in your head between millimeters and inches and things that have to do with that. So I think when we talk about that, because I mean, otherwise what happens is that we constantly talk about data as this one standard, and it's not really one standard. So that's the problem with data in general, but this data specifically. And then I want to admit something here at this point in time. So what we're going to talk about is we're going to talk about ice melting, and I think it's pretty important to talk about that, from the ice melting point of view. The problem is that at one point I had been given an analogy of if you take a glass of water and you put it on your counter and it's full of ice and water, that the water will not overflow. And a lot of the climate change, a lot of people that are so bent against climate change. And trust me, I believe in climate change, but as a natural course of events, climate always changes, always changes. They are putting it into a fact that climate changing is going to destroy us. And I do not believe that in a million gazillion years it's going to destroy us. I believe as a humanity has always come through this stuff, and we're going to come through this again. So I totally feel that things are not as dire as they are pointed out to be by the media, because the media, as I've stated before, is a self-licking ice cream cone. They make the chaos and then they report on that chaos. Make chaos, report on it. It's just this constant loop. It's like a self-licking ice cream cone. So that's what they do. So basically, what happens is that data in this case, I'm going to show you how the submerged ice in the glass will not overflow, but surface ice melting will overflow the glass, which I'm still trying to figure that out, because they're saying if you add ice to an already full glass, then the glass will overflow. So I'm gonna have to do that. I'm gonna have to experiment on that and figure out how that works. But anyways, I mean, because there is evaporation. I mean, the sun gives us evaporation, and that evaporation occurs, if something is melting, and what they call it, sublimation, when it goes directly from the solid to the gas, it just evaporates, it goes from solid and then immediately to gas, called sublimation. So I don't know how that enters into it. I am not a meteorologist, so I don't know, but I have a feeling that both sides are kind of going hyperbole on this. The one side with the glass experiment, and the other side with the surface ice experiment. So we'll talk about those things as time goes on. So what we'll do is we'll go directly to the data here. So I want to talk about billion-dollar disasters first, and then we'll talk about the ice flows and all that stuff. So there has been several news items. One by a meteorologist, and I'm sorry, but yeah, I get it. Basically, what's happening is, and I really appreciate the fact that local meteorologists are not getting into this, but the national meteorologists are. Every single word out of their mouth, I shouldn't say every single word out of their mouth, because that's hyperbole on my part. But every time they talk about the weather, sometime or other they're going to mention climate change. Because of climate change, this is happening. 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 I mean, the BBC is good at this stuff. They try to equalize it out. But at one point, it's I mean, they are blaming suicides on climate change. Suicides on climate change. I mean, this is like hysteria. I've never seen anything like this. I mean, what's next going to be? If people, if kids are born with one blue and one brown eye, is that going to be climate change? I mean, this is not good. This is not good, because correlation is not causation. So stop associating things without proper proof. Because all you're doing is you're correlating everything. I mean, correlating football wins to the fact whether I watch the football game or not. I mean, that's correlation, but that's not causation. So all these things, they're trying to associate all these things. It's just not, it's a real big problem for me as a statistician, as a data analyst, analyst, and as somebody who knows that this data can be manipulated to show just about anything you want it to show, as I'm just about to do here. I'm not manipulating the data. What I'm doing is I am normalizing the data. So this is standardizing the data. So let's go right to Excel here, and let's see what we have here. So I think that's pretty important. So this is storm events from 1981. Storm events from 1981, and you can see there's a ton of storm events here. 4,000, 4,500 rows here. So it's a big deal. And it's really great. Beginning time, end year, end day, end time. I mean, episode, event ID, different event IDs, thunderstorm, wind, hail, tornado. I mean, they have all kind of different things in here that they have. In fact, you can do a data and go to filter, and you can actually see. Whoop, I guess I had a filter. There we go. Let me try it again. Filter, and then we'll do event type. And you can see hail, thunderstorm, wind, tornadoes, and blanks. So in some cases, blanks. There's blank, for event ID. But hail, thunderstorm, wind, tornado are all included in the 1981 area. So what I did was I looked at the damaged property. I looked at the damaged property, and it's 25M for 25 million, 25K for 25,000. And I thought, now what do I do? I got, and a bunch of zeros. So I have to sit back and I have to go, now what, how does this all work? How am I going to, because it's impossible to sit back and do and add up numbers when they have a suffix as a letter. So it's an issue. I can do it categorically. I can do it, how many 25 millions do I have? How many 25Ks do I have? How many 5Ks do I have? But that's not what I want. I want a total. I want a numeric total of what is going on here. So what I had to do was, it's kind of interesting actually. So what I do is I had to say, okay, I have to take, right, I have to separate this M out. So I put the M out. Then I had to do what they call, I copied a 0, a 0, a 0, a 0, and a 25 here. And then what I did was, and this is actually kind of cool, I did a fill, well, let me just do one here. So if I take 0 and I put a 0 here, right, and then I take it right? And I just bring it down, you see it has a little square here. Well, I can do, I don't know what quick analysis, where am I here? So if I did, I mean, gosh darn, isn't that interesting? Let me totals equals spark lines. I don't care about any of that. So, oh, here it is. Okay, so what I need to do is, so I'm going to take, okay, so I'm going to just do a quick column here because I got to show you this. This is actually kind of cool. So I take this 0 and I put it here. And then I take a 0 and I put it here. I take a 0, put it here, take a 0, put it here, take a 25 and put it here. Okay, now, if I do that, right, and I start to come down, it's just going to, sorry, you're just going to add the 25s here. Now, this is called a flash fill. If I do a flash fill, what'll happen is it will fill it, you know, on this area. Now, what'll happen is that it should come out a little bit better than this. The flash fill shouldn't give you an 8, a 10, a 30, and a 40. It won't. It'll give you the 25, and then it'll give you a bunch of zeros here. Because basically what happens is, and then it'll give you another 25 here. It'll flash fill the entire thing. And so the nice thing about this, let me just dump this, is that it's very quick. So what happens is then once you flash fill it, then I take the M here, and what I do is I say, look, and then I take an if statement. If this AA2, right, is equal to K, then Z2, I'm going to multiply times 1,000. Otherwise, because it's the M, it's a K or an M, it's going to be multiplied by 1,000,000. And you can see automatically, boom, all these areas, see, they're all filled in correctly. Now this was nice. Now what I can do is I can take this at the end and I can add them up. When I add them up, the sum, I get $768,888,310 that damage to property. But it's $1981. So I had to go to what they call a CPI calculator and figure out how much it was going to be in 2023, and that was times 3.5, which is the CPI on that. And it ends up to be $2 billion. So guess what? In 1981, without counting hurricanes or anything else, just tornadoes and hailstorms and thunderstorms, we had over $2.5 billion worth of damage. That's just those storms. So everyone talks about these billion-dollar disasters. Well, guess what? Go back and take a look at 1981. Now, 1981 is more than 40 years ago. So if climate change is only taking into consideration 30 years, guess what, folks? You know, we had an issue back then. Now, did we go nuts? Did we talk about climate change? Did we talk about global warming? Did we talk about all this stuff in 1981? No, we didn't. You know, so this is what's happening here. Even if you go back, and I'm going to open up this one here. I have storm events from, should have storm events from 1950. Here it is. So I have storm events from 1950. And here's the damage here, right? And the damage from 1950 was 16,999,000 from 1950. You take that up to 2023 and you have $65 million. Now, this is totally tornadoes. There's nothing else here. In 1950, when this record keeping was started, and remember, this was all observation. There's no satellites. Remember, first satellites not until 1957. So you don't have any satellites. So what we have is we have $65 million just in tornado damage from observation. From observation. That's it. So I do a little bit more messing with this, but this is $65 million. So you have to sit back and go, gosh darn, Chris, that was, how long ago was this? This was what? 70 years ago. 70 years ago, we had $65 million. I mean, so, when you take, now that doesn't take into consideration hail, thunderstorms, hurricanes, anything like that, we still account for $65 million. So that is something that we need to take a look at and make sure that, hey, look, are we overstepping the bounds of saying, my God, we have billion-dollar disasters here? Well, guess what? We had billion-dollar disasters in 1981. You know, if the media really wants, and the thing is that you can mess around with this data as much as you want. You can sit back and you can say, you know, the media, if I were anybody famous, which I'm not, I mean, they would take this and blow this apart. And they would sit and say, well, there's a lot of other factors I have to take into consideration. And I counter that with, yes, in climate change, there are a lot of factors that have to be considered. You're not taking all those factors in consideration. All you're doing is you're saying, look, the ice is melting. Panic, 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 panic. You know, the ice is melting. It's the worst it's the worst in Earth history, because we've gone out and we've got a bunch of ice cores, and we sampled a bunch of ice cores, and we have determined that by sampling a bunch of ice cores that's the worst in 200,000 years. Right, right, yes, 200,000 years, because we know all the factors that existed 200,000 years ago. We know that. We know all the different aspects that were happening at that point in time. That would be a no. So that's what's happening right here. And I'm not saying that the climate scientists are not, you know, they're a bunch of kooks out there that are doing, you know, that are just kind of pulling stuff out of their heads. They're trying to deal with science from science perspective. But the problem is that all science, all of it has to deal with factors that enter into the scientific discovery. So basically what happens is, and probability. It's not just one factor. Cancer is not just one factor. You know, flu is just not one factor. There's a bunch of factors that go into that. There's a bunch of elements that go into that. And that's all I'm trying to prove here, is that this is, you know, go back and take a look at the data. This is the same data, this is the same people, NOAA and National Weather Service, that provide data on climate change. So I mean, I'm not pulling something from another area. This is a government website that you can go see. So I mean, and the thing is, I'm not busting on them. I mean, here it is. U.S. tornadoes, right? Look at this. You know, 1991 to 2020, average 81 tornadoes, right? This is what I have, and this is the average here, which is really nice. They put the average up here, and this is what's going on here. So I mean, this is 1 month, August. Let's go to September, since that's what we're in right now. So we go to September, we plot that, and it'll give us all this stuff in September. Look at the number of tornadoes in September. Now, why? Look at this. This is September. This is August. Wow, what a difference. What about July? Wow, even more, right? But what happens in September? In September, tornadoes come down, hurricanes come up, right? Now all of a sudden it's hurricane season. So that's what's happening here. And the time scale, they have 1 month, but you can really get down here. 3 months, 6 months, 12 months, year to date. I mean, there's a lot of things you can do here. So let's do 3 months, because then we're almost in the seasonal aspect here. So this is every 3 months, right? So this is July. Month July. Let's go. Let's do December. Okay. Nothing. I mean, not nothing, but I mean, look at that. Now all of a sudden we come up here into 2021. We have 400 tornadoes, folks. It's October to December 2021. We had 400 tornadoes. 400 tornadoes. That's really interesting. I mean, 2004 we had 254. We have 272 in 2018, and now they're saying we're having 400 tornadoes. You know, I don't know. I don't know about the data collection here, folks. I mean, it comes from the Storm Protection Center, and I get all that. But you're telling me that we went from October to December 2020, we had 70 tornadoes. 70 in 2020. We went to 400 tornadoes in 2021. 70 to 400. 70 to 400. And then back down to 156. I don't know. I'm just having issues with this. I'm trying to figure this thing out. How can you go from 70 to 400, right? 400 in that amount of time. I don't know. I'd love to check their data collection and see how they collected the data on that in that 2021 area. Um, I'm just not sure about that. I mean, this in the data world, when you have that type of disparity, there's something going on. Either the data is not being collected correctly, it's, there's a definition that has been changed somewhere along the line. Something is happening here. But that is way too much of a difference here. So let's see, if I do January, would that be a difference? See, I mean, again, we're talking November to January, 290, and they're estimating here 160, and uncertainty, they're talking about 288 possibility. Again, I don't know. It goes from 67 to 290. I don't know. Again, I'd love to see this data, the raw data. I'd love to see the collection of the raw data and see exactly what's going on. So I may go and, I'll take a look at this data here, because it's saying 2023 November to January. So you can actually see, like I said, you can actually see the data. But the data is going to reflect what this is all about here. So 2021, and it's just, and then you can take it down to your Excel or whatever it is. So, I mean, I don't know. If you do 1 month, let's plot just 1 month in December, and they're saying 1 month in December, just December 2021, you had 232. Just 1 month, December 2021, went all the way down to 58. This is 27, and this is 232. Snap. There's something wrong here, folks. You can't. I mean, weather is weather, and I get that, but really. So, anyways, I'll go and try to get the actual data, and we'll do whatever we need to do to make that see how that all worked, because I'm just not sure about that. So then we go from the tornado aspect and the collection data and all that into it says Antarctic sea ice at mind-blowing low alarms experts. Okay, so let's take a look at this for a second. So this is daily sea ice extent in million square miles, 1979 to 2023. So here you have these lines, right? Each line, and then you have the 2023 line here, which is an outlier in this area here. So you see, but I don't know what this is. Million square miles. So this must be million square miles, I guess. So they're talking about different aspects and what's going on, but I want you to take a look at this. 14 September median extent. Now, to look up median, got to look up median. Okay, that's actually a good measure. That is a very robust measure, better than mean. Okay, 1981, 2010. Okay, median extent. So it was all the way out here, and it looks like in the north side here, and part of the south side, it looks like it's back to here, back to this area. So the loss of land ice from Antarctica has contributed 7.2 millimeters to sea level rise. 7.2 millimeters to sea level rise. Then they talk about modest increases. Well, what is 7.2 millimeters? So just look it up. So millimeters to 2 inches. All right. So we're going to look up millimeters to inches. So what was it? 7.2. And that is 0.283 inches. 0.283 inches. For an approximate, divide the millimeter value by 25.4. So this is what you have here. 0.283 inches. Okay. First of all, that's not even a third of an inch. That's not even a third of an inch. Third of an inch rise. So what'd they say? Since the 1990s, which is 30 years ago, the loss of land ice from Antarctica has contributed 7.2 millimeters to sea level rise. Okay. First of all, I'd love to see how they did that. That would be really cool. But let's just, for the sake of argument, say they're right on. 0.283 inches. So I'm going to put this on the screen here, because I think it's like, I think we need to do so. 7.2 millimeters is equal to 0.283 inches. All right, not even a third of an inch. Okay, not even a third of an inch. So 7.2, right, 2.283, right, 0.283 inches. Not even a third of an inch. A third of an inch of sea rise. Now, okay, since the 1990s, it's 30 years, folks, which is when we talk about climate change, they're always throwing that 30-year mark at you. Okay, fine. It's changed in 30 years. We lost the amount of land ice has contributed 7.2 millimeters. Now, when I say 0.283 inches, what does this mean to you? It's like, well, that's really a small amount. But if I say 7.2 millimeters and you don't have any idea of what that conversion is, all of a sudden 7.2 millimeters sounds like a lot. Like, oh my God, because I know what 7.2 inches is. You know, that's a half a foot. So 7.2 millimeters must be really close to that. And therefore, we have to start panicking because 7.2 millimeters, my God, that's so much. No, it's not. Not even a third of an inch. Now, is the sea level rising? You know, again, I have to take the scientist's word for it, which I'm hesitant to at times because I've been in the data collection, data analytics business for a while, and I see where this is all probability aspects. So I don't know how they're figuring this out, you know, from that standpoint. I'm sure they have some mathematical formula they're throwing at it, but bottom line is that 0.283 inches is not that much. I mean, I'm going to tell you right now, if somebody was telling me that that our little pond here, you know, and our community was rising 1/3 of an inch in 30 years, I would sit back and I'd go, really? I'm sorry, but I'm just not panicked about that. You know, I mean, really at that rate, we're talking about 90 years before it raises 1 inch. 90 years. If everything remains the same, which it never does. Now it could raise the rate of rise could be much quicker. Now that's where you get into prognostication and you get into guesses, which is really intelligence guesses, but they are guesses nonetheless. And so all of a sudden it's like, you know, this is our prediction. You know, it's going to overflow Miami, you know, in a matter of, you know, if this keeps going at this rate and all this stuff. Okay, you know, I mean, good a guess as any. I'll go with that. But I mean, if that's the situation, but that's what's happening. And so, you know, when you talk about climate change, you talk about different aspects, please check the data. Just go and check it. Go and check this data. I mean, like I said, that 1 year, I mean, what was it, 2021, where that all of a sudden it was like 400 in 3 months, 400 tornadoes, 400 tornadoes. There's only 50 states, 48 of which is contiguous. You're talking about, if it's 50, you're talking about 8 tornadoes in every single state. 8 in every single state of the union. So, I mean, I don't know. I don't know about that. I'll have to get back to you guys next week and check this data and figure out what's going on. But I wanted to present those two things to you just to give you an idea as to what's going on and to tell you that the surface ice, and when we talk about surface ice now, they talk about the idea of surface ice and the difference between surface ice and let me throw this up real quick. If melting ice cubes don't overflow full glass, why are melting glaciers an existential concern? So this is, originalnewsbreak.com, and they give an answer right here. So you can always take a look at this and see what you think. I mean, it's a good argument. I mean, I take a look at it and go, okay, you know, that's an interesting argument. All right, it's totally different. I stand corrected. So I'll have to take a look at that and see exactly what's going on from that point. And in the meantime, I'm going to tell you, keep checking the data. Very, very important. And have a great rest of your week. And remember the data show here on Thursdays at 2 o'clock at Roku TV, Pod TV, and also on YouTube as you see fit to take a look at it. Thank you so much for watching. Have a great day.